Hello guys, so in today's lecture we are going to talk about an ideal fermenter. So before talk about this, we should know what is fermentation and why this carry out. So fermentation, it is a biological process in which a sugar is fermented and result into alcohol and CO2 plus CO2 is a byproduct. Fermentation of sugars by using yeast. So it is called a fermentation in a simple language. So in industry we need to produce lots of things, lots of byproducts of the various organisms. So this is not the only thing we produce lots of things. So for this we have to give an ideal condition to organism to grow and make a excess amount of metabolites which we require. So for this we require an ideal fermenter. If we want to define an ideal fermenter, then it is an apparatus or instrument which maintain optimum condition for the industrial important organism. It is called ideal fermenter. So in which instrument we can say ideal fermenter, it should have some characteristic. So it must contain an agitator to provide a pure air, mixing, an aerator by which the air is circulated into the fermenter, a proper temperature, a proper pH. It should be maintain a variety. It should be available for a variety of organism, not a single organism. So for that, industry must be in the loss, not get a profit from getting this. So there are lots of characteristics, like it must be a non-corrosive, it not be not toxic. So there are some characteristics which should fulfill to become an ideal fermenter. Now if we saw the figure, you can see into the image, but I also draw roughly to explain you each and every part of an ideal fermenter. So I just drawing roughly. This is the main thing, amazing thing for any industry, that it should be getting an ideal fermenter right. This is a agitator. The second name is pedal wheel or impellers. This is a pH control. This is a motor which rotate the impellers. Here the feed pod and other things. Here the coil. This is the cooling jackets. So we just giving a single part and getting each and every part's information that why is required. So cooling jacket. So during fermentation reaction, an organism is in a process, so it must be released some heat. So due to heat, it changes the environment temperature. So it not be ideal for which it is required for their best growth. So cooling jacket, what to do? If temperature increases, then the cool water flow starts from here to here, and here the hot water is released, continuous flow. So by this the proper temperature is maintained. So this is the work of cooling jacket. Here the agitators are there. What they do two things. First, mixing of nutrients, and second thing is mixing of air, which is provided by the sparger. So the impellers, it's maybe 4 types or 5 or 6 types. I just give the name. Open disc turbine, Venet disc, marine propeller, scaba. This fine name I remember. So if I mention then open disc turbine, scaba, and marine propeller, and another was Venet disc. So they are they are made different types and shapes. In different fermentation they are used. So that was the impeller or paddle wheel or agitator. The next thing is a sparger or an aerator. Sparger or aerator. What it do? It provides air, because in aerobic condition the O2 is required for each and every organism, because O2 is a terminal electron acceptor. We all know it's a T-terminal electron acceptor into ETC cycle. So in anaerobic condition the other air is required. So proper mixing of air is required. So a sparger may be a different types. A sparger types, if I mention, then it must be a porous sparger, nozzle sparger, orifice sparger, and the fourth one is a combined sparger, combined with the impeller. So these four types of different sparger may be used. One of the sparger is used. So best use is orifice sparger and nozzle sparger. What they do in a porous sparger, the sparger look like that. Film. So small pores are present and it will release the air. So main drawback of the porous sparger is invasion or blocking of pores by organisms or any nutrients. In nozzle sparger, a single line is there and he will flow the air with a full of pressure. So in this, the invasion of the blocking of air is not occur. In a orifice sparger or in a combined sparger, what combined sparger? So sparger is connected with here, with impeller. So with impeller is moved, the sparger is moved and the air is efficiently spread over the fermenter. So this is the work of a sparger. Now I forgot to mention one thing into the fermenter. That was the main thing of fermenter. It is a baffles. So this is the baffles. What baffles do? Baffles are 4 baffles are present in a 90 degree of a fermenter, and like that with a full of sharpness. What they do, due to mixing, we done a experiment in a childhood that we just mix the water. So as we mix, the vortex is formed. What form vortex? And due to what is the water flow is come up. So if it reaches the here, then the positive pressure will be decreases and contamination chances increases. So to maintain this, baffles are present. So what do baffles cannot? It's avoid the vortex formation, because if you in a protein fermentation, mainly the vortex is very high much is present. So baffles is a heart of a fermenter to do the avoid the vortex formation and remain its purity aseptic condition as it is. The next thing is a anti-foam agents. It may be added subsequently or before the batches start. What anti-foam do? During the fermentation, the foam is generated, as we know, and due to foam is goes higher, and the do same thing what was the vortex do. So due to this, anti-foam agent should be added, so a limited foam is generated and not more than limited. So it may be drawn mechanically or direct, that if it is the certain point, then a computerized anti-foam agent is added and release the foam. The next thing in the fermenter is a feed pot. A feed pot may be a second hard thing. Feed pot is located here. Here the feed, continuous feed is present. In continuous fermentation, the continuous feed is added, but in a batch fermentation, the continuous feed is not added. So feed pot may be sterilized both the time and both the way. In situ, outside and inside, both the time. The pH control also, here the pH control is there. pH is also a main factor to a growth for a certain organism. So this is all about an ideal fermenter. So I hope you learn, and I hope now you can define what is a perfect ideal fermenter now, and you can go whether any of the industry you can see and observe, yes, it is the ideal fermenter. I hope you learn. Thank you. Stay with Ravi's Biology.